What's up guys, my name's Donnie and welcome to Student Math. In this video, we're going to see how well we have imbibed the knowledge. It's kind of like a short stop. I prepared 3 problems in total. I want you guys to pause the video and then first solve the problems by yourself and then check it with me if you got it correct. Great, let's start. Tom has 3 red flags, 2 blue flags, and 3 green flags. If he is to make signals by aligning 3 flags in a line, how many signals can he make? So he has 3 red flags here, and then he has 2 blue flags, and then the rest are going to be green. So this we've solved this problem kind of something similar before. I wonder if you guys have noticed, but this is using a permutation because we're going to find out aligning the line, and this is also using combination. So let's see first. So there's 3 green flags here. So first we're going to choose 3 flags out of how many? 3, 2, 3, that's going to be 8. So we're choosing 3 flags out of 8 first. And remember the combination with repeated values. That is what exactly we have here. So the equation for the combination with repeated values was total factorial over, we have 3 red flags, 3 factorial, 2 factorial for blue flags, and then 3 factorial for green flags again. That is going to be, so if we simplify this, it's going to be 8 times 7 times 6 times 5 times 4, because it's going to be cancelled out from 3 factorial from both the numerator and the denominator. 2 times 1 times 3 times 2 times 1. So 3 times 2 is going to be cancelled out with 6. 2 here we're going to be cancelled out with 2. So we have 8 times 7 times 5 times 2. 8 times 7 is 56. 5 times 2 is 10. Times 10 equals 560. So we have 560 possible number of events of choosing 3 flags out of 8. So we need to find out how many signals can he make. So let's say we have random 3 flags. If we are to put these flags in a line, straight line, how should we do it? Simple. We're using value of permutation, 3 out of 3. We're choosing 3, which equals 3 permutation over 0. 3 factorial over 0 factorial, which is 3 times 2 times 1 equals 6. So now we have the number of values of choosing 3 flags and aligning 3 flags in a line. What should we do? Simple. Multiply it. 560 times 6 equals, let's divide that up for a sec, 500 plus 60 times 6, which equals 3000 plus 360, which equals 3360. That is the answer. Let's go. Second problem. Rosa is planning to paint the pyramid. She has 5 paints. She doesn't want the signs that are connected to have the same color. How many different ways are there for her to paint the pyramid? So let's draw this into a diagram. We have a pyramid here. We have a pyramid. And if we see this into a flat diagram, it's going to be something like this. This should be more even here. Okay, let me draw this in a better version. Should be right about here. All triangles in the same side. Rectangle looks like a square. Here we go. So she says she doesn't want the sides that are connected to have the same color. So what she wants is, if we color this side with brown, none of these 4 should have the brown color. This is kind of tricky. So what should we do here? First, we put the criterion on the base. So let's say we chose a random color out of 5. How many possible values are there for choosing a base? There is 5. There is 5. Now let's see. Now we need to choose the color for the rest of the 4 sides. 4 sides. Oh, sorry. We're going to choose how many colors we can choose for the 4 sides. I hope you guys remember the equation for the circular combination. No, the circular permutation. It was that if there's a family here, let's say we have 4 family, then the number of values they're going to set is going to be 4 minus 1 factorial, because each side they moved 1 to the left, it's still going to be the same thing. So for example, if there was a mom here, father here, a daughter, and a son, MFDS would be exactly same as MFD. These two are the same, it's just that they move one side to the left, because this is going to be happening 4 times. We're dividing it by 4, so 4 factorial divided by 4, that's the more precise function, and that becomes 4 minus 1 factorial. And that is what we have here. If we just turn this pyramid one side to the left, then we are going to have 4 same repeated kind of pattern. So what that means is that all we have to do is there's 4, the n is 4 bases. It's going to be 4 minus 1 factorial, which is 3 times 2 times 1 equals 6. So the answer is 5, the number of possible events you choose the base, multiplied by 6, the number of possible events you color the 4 sides, which equals 30. That is the answer. The last question, NPR equals 210, NCR equals 35. What is n plus r? So let's simplify the equations first. NPR equals n factorial over n minus r factorial, which equals 210 here. NCR equals n factorial over r factorial, n minus r factorial, which equals 35. So if we divide 210 by r factorial, that means it would become 35. So let's just change the denominator and the numerator. So r factorial over 210 would be 1 over 35. You multiply 210 in both sides. R factorial equals 210 over 35, which equals to 6. 3 factorial equals to 6, so r will be 3. So we got our r here. Let's start getting the n now. So NP3 equals 210. NP3 would become n factorial over n minus 3 factorial, which equals n multiplied by n minus 1 multiplied by n minus 2. And this is because, as previously mentioned, all the n minus 3 factorials from both numerator and the denominator will cancel out. So this becomes 210. 210 210, if you factor it, it becomes 7 times 30, which becomes 7 times 6 times 5. We got the consecutive numbers here, which is what we need from here. So n equals 7. Oh, sorry, n equals 7. We got the n and the r here. So n plus r equals 10. There's another way solving this. That is by just simplifying the equation and making this into n third minus 3n squared plus 2n minus 210 equals 0. And you can just use it by yourself or use a calculator. That's also another method. Great job, guys. We've all done it.